Okay, so we're just going to look at a few questions. I think I brought out 4 questions from a recent paper. If we can just look at those 4 quickly, we would have done ourselves some good justice. And the first one would be electrochemistry. If we can get the electrochemistry right, we would have done some good work. Let's see. Let me see how many marks is this electrochemistry. Electrolytic cell 15 and galvanic cell 14. That's a lot of marks. That's about what? That's 30, 29, 30 over 150. And what would that be? 20%. Which is very, very important. If I were to allow you to just peruse this question, how would you fare in the first 4 marks? Let's see. No, you can't be getting 0. Look at that definition. You can't be getting 0. No ways, I refuse. Write down whatever that comes to your mind quickly on this. But read the question first. Read the question and write down whatever comes to your mind. You need to go on YouTube and find the songs on this. It gives you all the definitions that you need. Or, if I played for you, you'd find the first one there.
So just to recap, how do you differentiate between endothermic and exothermic?
All right, I'm going to just tell you this. Electrolytic cell is endothermic. Galvanic cell is exothermic. Here, because we are using electrical, we're taking in electrical energy. Okay. Are we ready to answer? Can we mark? Let me probably in 5 minutes just show you a few things that you need to know. 5 minutes. Just to summarize quickly. I love to always do a summary. Okay. So if I look at a galvanic cell as quickly as possible, let's see. No, an electrolytic cell rather, as quickly as possible. And I'll be giving you things that I know would definitely be in any paper. Electrolytic cell. What is the energy conversion? Look, it starts from the word elect. So you know you are converting electrical to what? Chemical energy. And what type of electrical energy are you using? It's a DC. It has to be a DC. And what is the purpose? We go back to paper one. We have AC and DC. AC is what? Alternating. DC is direct. Why are we using DC? To keep polarity of the electrodes. To keep the polarity of the electrodes. It is an endothermic reaction. It is an endothermic reaction. Generally, electrons flow from where? From anode to the cathode. Alphabetically, is from A to C. Alphabetical order, A to C. What do you know about the cathode? An important point is the cathode increases in size. Another important point, I should have mentioned it here. If you, okay, I'll put it here. Ape. The anode is positive in the electrolytic cell. The anode is positive in the electrolytic. So these are simple points that will help you navigate through any question. The anode is positive in the electrolytic cell. Just a quick summary, like your cue cards that you need to quickly read here. We have the processes of electrolysis. All right? Look, throughout all the cells, the process, it's only 3 steps. Number 1, the breaking down of electrolytes. Breaking down of electrolyte. So your electrolyte is an ionic solution that conducts electricity through the movement of ions. I think I've answered the first one now. It must be an ionic compound because we're looking for the transfer of electrons. If you go back to your grade 10, ionic bonding. So what happens? Step 1, your compound X plus, or let me say XY, would break down into what? X plus Y minus. Would break down into X plus. Usually, this one is a metal. Usually. And the positive ones are called what? I just use the spelling. Spell cat. C-A-T, right? C-A, and there's a plus there. That's what I use. So I know that, the one that has a plus, the plus looks like a T. Those are my what? Cations. And this one becomes my... All right, so this is my first step. And in my first step, I'm trying to... remind me, we need to... Okay, this process is called what? Electrolysis. What is electrolysis? Very simple. Check here. It is a process of doing this. What would you say? It's a process of converting electrical energy to chemical, and I'm done. All right. So it's a process of converting electrical to chemical. Okay, step number 2. What happens? The migration of ions. Let's use synonyms. Synonyms are what? What's that sound like, right? Good. Cat and an. It means the cations would go to the cathode. And the anions would move to the anode. I want you to see the beauty of what I just explained here. And I'll show you now. So we use synonyms. Cat would go to cat, an would go to an. All the time in electrochemistry. If they ask you where cations are going, no, it's the cathode. Where are anions going? The anode. Check here. I want you to see the connection of what we just did. Anions are what? Negative. Under electrostatics, what do we know? The negative should be attracted towards the... So it means the anode is what? There we go. Make sense? So the anode is positive in the electrolytic cell. So it's going to put an arrow there. There. Makes sense? So the negative would go to the positive, and the positive would go to the... Why am I showing you this? They're going to give you certain questions where they just show the cell, plus and minus. Which type of cell again? It's a DC. Why a DC? So the anode will stay the anode throughout. Because if it's alternating, what's going to happen? Positive at one point, negative at the other point. We don't want that. Okay. And step number 3. What is step number 3? Redox. What does redox mean? Reduction and what? Oxidation. Where does reduction occur? All right, let's do something quickly. I don't want you to cram. I don't want you to choose. Strain your head. Use the formula page. Can I quickly put a formula page and see what's going on the formula page? Very beautiful. Use your formula page. Let me see if I can get one here. I hope this question paper has a formula page. Oh, great. We've got one. Beautiful. Yeah, I don't like the way it's written, but it's okay. I just want to cut this out. Look, don't stress in the exam about this one. What do you notice? EMF equals to what? E cathode minus E anode. There are 3 definitions there. If you go down, what does it say? E reduction minus E oxidation. Next one, E oxidizing agent. You know what I do? I just read downwards. What happens at the cathode? Reduction. What is reduced? An oxidizing agent. What happens at the anode? Oxidation. Right? Which one is oxidized? The reducing agent. What is the symbol for electron? It's an E. Okay? Let's create something nice out of this. If it's an E, what does the negative tell you? Loss. Mathematically, can we agree that there's a plus here? Okay? What does the plus tell you? Gain. And I know E stands for what? We're just trying to be creative here. What is oxidation, if I were to ask you? Oxidation is the of good. What is reduction? I don't know if it makes sense. Yeah. What is an oxidizing agent? It's a substance that, what's the sign here? A substance that what? Gains electron. What is a reducing agent? It's a substance that what? Loses. Can you see all the definitions we're picking up from the table? From the formula page. Make sense? So what's happening at the anode? Check. What are we doing? Losing what? What's happening at the cathode? We are So if I'm gaining weight, how would you see it? I become fatter, right? So what's happening to my size? It's increasing. So the cathode is gaining electrons, it will increase in size. The anode is losing electrons, what happens? It will decrease in size. Just play with your formula page, and there's a lot going on here that you can pick. I don't know if it makes sense. All right? So you just gain, you lose, all from here. Check. If the anode, therefore, is losing electrons and the cathode is gaining electrons, how are electrons moving? The anode, I'm losing 5 rand, you gaining 5 rand. What is the flow of the 5 rand? From where it's lost to where it is gained. So electrons always move from anode to, because it is lost there and it is gained there. We play around with this and we just see a lot of things going on here. All right? I see there's a lot of people joining. That's good. Okay. Did it make sense though? Yes. Negative is loss, positive is gain. And you just read along that way. So, I am done. I wanted to explain reduction and oxidation. I'm done. What is important here before we answer the question, and I'm also dealing with your galvanic. This is general electrochemistry. But what is important here is your ability, and I want you to listen to this, to apply. Can you write your half reactions? If you don't know how to write your half reactions and interpret, you will be losing marks. And let me tell you, they are going to ask you questions based on you being able to apply and see what's going on. How do you write? I don't know. We have so many learners in class. I don't know how we write, but for us, this is what we do. Number one, half reactions. Let's quickly look at that. I'll look at 2 things on this particular page, and then we will be answering our questions now. Half reactions. I use my 4B table. I use the 4B table. So when you get to the exam on Monday, please take a pencil, cancel 4A. Just to rule a line. In fact, if you can rule it well, let me say that online. Because I would have said, once they say start writing, just take a pencil, put it across 4A. Just remember, A needs to be cancelled. You're working with 4B. Nikita, I'm not sure yet. I'll decide. I'll see how I feel about that. But maybe I should. Okay. Now, if I look at 4B, look guys, if you look at 4B, then everything will always be alphabetical order. How will your electrons move? Alphabetical order. A to C, right? Good. So if I use 4B, check what I'm saying. It is A. The one I find on top, that will be my anode. And the one I find at the bottom will be the cathode. Always. Don't even stress. Okay. Can we do a bit of politics? There's a political party that looks as if I'm writing a political party here. What is it? So it's the anode and the cathode. Anode and the cathode. Okay, we don't want to be political. We are GNU. Okay, GNU. Anode and cathode. Now, if you look at the political party I have here, there's a particular president. Nice president. Jacob Zuma. Yeah, I see you are a fan of Jacob Zuma. You are a fan. Let's write the letter Z. Jacob Zuma is my science teacher. Guy taught me chemistry. So if I'm writing Z, it goes that way, right? And it goes that way. And I have a line in between. So I think of the A and C, and I think of... why am I writing my Z like this? I think of the president, and I think of Jacob Zuma. Make sense? You know what I've simply taught you? When you're writing your reactions, for the... What happens at the anode again? Oxidation. I'll go from my right to the left direction. When I'm writing my cathode, what happens at the cathode? Oh, reduction. So I go from the left to the right. Does that make sense? Okay. Grade 4, grade 5, grade 6, 7, 8, 9. What do you call somebody who's copying your work? If somebody's copying your work, what do you call them? No. Don't go fancy. This is just a simple, what we call them. Tanana. We call them, good. We call them a copycat. Check. We call them a copycat. What are you saying? Copy the cathode. Once you identify the cathode, just copy, because it's already from left to right. You just go into your table, copy, but make sure it has only one what? Arrow. Okay, finally. Oh, I talk too much. I wish I could talk like this and ask you to answer on Monday. Then, are you done? Okay, next question. I talk again. Guys, now answer. It will be easy, né? But I'm sure today's paper was easy. I'm looking forward to getting... Okay, all right. Do you want water? Okay. Because the way you are coughing... Okay, quickly. Just to round this up now. Let's look at the processes we spoke about. Application of electrolysis. Again, I'll forward the songs on YouTube to you. Application of electrolysis. It will really help you. What are the applications? Number one, there's electroplating. Why do we electroplate? For appearance purpose, for protection from rusting. Those are the basic ones. And what is electroplating? It's basically the act of covering a metal with another metal. So you take a metal and cover it with another metal so that it appears nicer. I always share my experience with my mother whenever I talk about this. My mother had some golden spoons. And I know whether you guys have it as well. No one is allowed to use them except visitors. Yeah. She thinks they are gold. Shame, they deceived her. Yeah, they deceived my mom. She thinks, whoo. For me, one day I actually went to use the spoons to eat when she was not at home. Because I was like, do they taste different? Because why are we not allowed to use them? When she was not home, I went there. This didn't taste the same. Forget. Because I thought, okay, why are visitors treated specially? You know, when they're coming, we bring out the plates. It's gold. I can still picture them. But it's not gold. Huh? Yeah, it's a gold leaf. So it was just a painting. Painting with gold. Why? To look better, to deceive people who don't know. Number two, protect from what? Rust. But here's the thing. I want you to think about this, guys. If I want to electroplate a ring or a key, for example, what am I saying? I want to electroplate a ring, what are we saying? I want to see gold on the ring, right? That's what it means. To electroplate a ring. So the ring is not gold, but I want to see gold. This is what I like to say. We see at sea. See. We see at the cathode. So the ring must be at the cathode. Whatever I want to electroplate must go where? Because we see. I want to see gold on the ring. So I can only see at what? C. So whatever needs to be electroplated must be at the cathode. All right. Item to be electroplated. Item to be electroplated should go to the cathode. That's one. Number two, we use a salt of the type of material to be used. Material to be used. For example, if I want to cover with zinc, what do I use? A zinc salt. If I want to cover with copper, what do I use? A copper salt. If I want to cover with gold, what do I use? A gold salt. All right. Number three, the anode also. The anode is made of material to be used. And this is very important. if this happens, the concentration of the electrolyte remains the same. They're going to ask you this one. Remains the same. I'll explain when we get to that question. The concentration of the electrolyte, why? The rate of reduction will be equal to the rate of oxidation. And this we are going to pick from our half cell. And I hope you guys can balance. Can we balance? Everybody in the house, online, physical, can we balance? These 3 marks to be able to balance. All right, good question. Can you use any salt? Absolutely. But most preferably, please, use, if they ask you for salt, use a nitrate. Why? All nitrates are soluble. Be careful. You can use chlorides, all right? If you use chlorides, make sure you are not using not silver, not mercury, and not lead. These chlorides are not soluble. Is it barium? Just confirm something. But silver, definitely not. Mercury, not. Is it barium or lead? This is grade 10. Well, you're laughing. It's grade 10. And once you see silver chloride, know that there's a problem. The examiner is tempting you. All right? Yeah, I'm correct. Lead.
So why can't you use it?
Because they are not solutions. They are solids formed from 2 liquids. But what did we say about our electrolyte? Electrolyte must be solutions. All right. Once you see them, there's a problem. I'll get to this problem when I get to galvanic cell. All right? Let's move quickly, otherwise I'll keep talking here. All right, sulfates, you can use sulfates. Sulfates are also soluble. All right, but preferably just stick to nitrates. Anything nitrate soluble. All nitrates are soluble. All right. Electroplating, we're done. We'll do the half reactions. Number 2, quickly. Electrorefining. Electrorefining. Ooh, this is the crash course. What do we do with electrorefining? We purify metals. Why do we purify metals? This is purification of metals. 4, increase conductivity. Increased conductivity. For example, we get copper. Copper is raw. It has impurities. What do? We purify to increase the conductivity of copper. Like, for example, your copper wire. So if it is having impurities, the conductivity is not going to be 100%. So we make it pure for what? Increased conductivity. Here I'll just say 2 things. The impure metal and the pure metal. The pure metal should be the cathode, and the impure metal should be the anode. We want to see the pure thing on the pure metal. So, at the cathode. Number 3. Sodium chloride electrolysis. They love this one. This one is a delight. They love it. They love it. Sodium chloride solution. They love it. Let's just break it down quickly. Number one, what happens? We're going to have NaCl breaking down into what? Na plus Cl what? Minus. But because it's an aqueous, what happens? It is surrounded by what? Water molecules. Okay? So it's an aqueous solution. It is surrounded by water molecules. What happens? The Na plus, which are my what? Cations, will migrate to the cathode, while the chloride ions, which are the anions, will migrate to the what? Anode. We good? By the way, I know I'm moving quite fast. Is it too fast? Okay. By the way, what happens at the anode? Oxidation. Okay? So, which one will be oxidized? The chloride ions will be oxidized. And that will give us 2Cl minus Cl2 gas plus what? Please don't cram it. It's like this on the formula page. It's right on your table. You just write backwards. Right from the right to the left. Watch what is produced. It's a gas. Examiners are going to ask you something. What is observed? It's a green bubble. Observation. Chlorine gas is green in color, but how do you know a gas is released? Bubble. If you blow air in water, what do you see? Bubbles. So sometimes they ask that, okay, write what will be observed. So you see the presence of a bubble tells you what? A gas is given off. What about reduction? What are you expecting? Sodium to be reduced. But sodium will not be reduced. Water would be reduced. Plus 2E to give me H2 plus 2OH minus. It's right there on the table. I think it's 0.83. Just take note of it. Yeah. It's 5 under, so if you look at sodium from the top, look at sodium, I think you count 5 downwards, you'd find water. How many? Somewhere there. From the top, sodium. 1, 2, 3, 4, 5. That's it. 5 downwards from sodium. And they're going to ask you why. Why is sodium not reduced? Sodium ions are not reduced. And this is what you're going to say. Water is a stronger oxidizing agent. This is 3 marks. Than sodium ions. Hence, water is reduced. We are going to do net ionic equation, which would represent all of these equations. If you wanted to cram anything, you work it out afresh. All right. Are we okay so far? Let's see. Let me get a response from those at home. Are we okay so far? It's just a quick crash down, on awesome. Okay. Finally, the electrolysis of copper chloride, another common one. Number 4, electrolysis of copper chloride. And this one comes in 2 phases. Chloride. It comes in 2 phases. A, using copper electrodes. If I use copper electrodes, will there be a difference? Will the reaction change if I change the electrodes? That's going to be the question. Let's talk over it quickly. So if I have that, positive and negative, these are what? Copper electrodes. And what do we have as an electrolyte? CuCl2. By the way, copper ions are blue in color. Blue. Please take, that's a very, very important point in chemistry. Wait, I didn't finish. Can I go back to that other cell? Just before I forget, please. Now, remember, we are producing this, right? Oh, by the way, how do I see this again? Bubble. And please go and know the test for hydrogen gas. Test for hydrogen gas. Oxygen is the one that gives a pop sound. Hydrogen gas. If I put a glowing splint where there's hydrogen gas, it would glow. So like, for example, I strike a match, all right, and I put it off. You know, it's still glowing a little bit. If I put it near hydrogen gas, it would glow again. All right, so hydrogen, all of this is grade 10. Test for hydrogen, test for oxygen. Do you remember grade 10? I know you don't. All right, but check the key thing here that the examiner wants to test. What are we producing here? Hydroxide ions. What do we have here? Now, what do you notice? We form NaOH. So they'll ask you, why is the solution alkaline? Because a base is formed. Because we have sodium ions left, and we are now forming hydroxide ion, so we form. Can you see how we brought in acid and base? Sorry. We have brought in acid and base. Okay. Huh? You want me to go back? We form acid and base. Okay, finally here. And then we answer our question. Okay, I was saying, first, what do you notice? This Cu, remember this is what? Our positive. And this is what? Negative. Now what are we going to have here? Cu2 plus and Cl what? Minus. Where will these positive ones go to? The positive ones would go to the negative, and the negative ones will go to the positive. Are we together? So what do I have here? I'm going to have Cl minus. And what do I have here? I'm going to have what? Cu2 plus. Is that okay? Okay. By the way, what is this? This is my anode. And this is my cathode. All right. What am I expecting at the anode? Oxidation. What am I expecting at the cathode? Reduction. I am going to compare what I have at the anode and cathode. I'm sure everyone, you should please have a table there. All right, you should have a table there. Check at the anode, what do I have? I have copper and chloride ions. I have copper solid and what? Cl minus. Which one of them would be oxidized? Use your table. The first one you find, and I'm going to tell you how to know which copper to use. The first one you find, let me grab a table as well with you. The first one I find, remember I'm using which table? 4B. Don't even go near A, just cancel it. Give your examiner that one. Say, keep for me. I'll collect after when I'm done. Just keep. I'll take it so you're not tempted. Look at this. If I use my table, this is my 4B. Let's go from the top. What are we looking for again? Cu and Cl. Okay, are you following? Are you following so far? Guys, I'm going to tell you which copper to use. Please remind me. All right. At the moment, I'm looking for Cu2 plus 0.34. Okay? Put that in your head. Oh, did we find it? Somewhere there. All right, guys. Can you see it? Okay, I have 15 minutes on this call. I'm going to send you another link on all the groups for you to join in. Okay. Hello, Nana, you made it. Okay. All right. Which one are we seeing first? I'll put it there. Can you see CU2+? Yes, all right. Let's see if I can highlight. Oh, it's going to take me time. Oh, let's see. Ah, no. If I perform this, it's going to, let's see, it will take me time. It's going to take me some time. All right, but you can see Cu2+ there, right? Where's chlorine? Let's go look for, can you see chlorine is underneath? The first one you find will be what? Oxidized. That's what we're saying. And what are we expecting to take place here? Oxidation. So which one will be oxidized? Which one did we find first? Copper. So what's going to happen? Remember, we start writing from the right to the left. So what do we have? Cu to give us what? Cu2 plus what? 2E. This is a solid. I want you to learn the interpretation here. When you see a solid going to aqueous, what's happening? It's becoming smaller. This means it's dissolving. It's becoming what? Small. And this is the anode. It makes sense. The anode is the one losing electrons. The anode is the sick one. This person is sick, losing weight. All right? What's the cathode doing? Gaining. And you can see, that's you. Okay. So this is the anode. Now, what happens at the cathode? Do you notice at the cathode, it's copper? There's no need to go and check on the table. They are both copper. Make sense? So what's going to happen? Copper will be what? I said copy, cat. What's happening at the, which one is at the cathode? Copper, right? Again, copper 2+. Please remind me, I will show you how to choose the correct one. Check there. Copy, cat. So what do you write? Cu2+ plus 2E to give you what? Cu. Cu2+ plus 2E to give us what? Cu. So Cu2+ plus 2E. Wait, what are we doing? Moving from what? Aqueous to? What's happening? Increase in size. Because we are gaining. We are forming a solid. All right? Increase in size. What is the net ionic equation? We add both of them together, right? Because it's 2 electrons, my answer would simply be what's on the left? Copper solid. What's on the left at the one below? Cu2+. Are you with me? To give me what? What's on the right? On top? Cu2+. What's on the right at the bottom? Cu. What do you notice here? Are you lost? Okay, great. Don't whisper. Talk. Where are you lost? My net ionic. Which one? Where?
So, copper is going to be oxidized. The cathode, copper again.
Copper ions will be reduced. We're just checking on the table to see. Don't cry. Don't try to. We just look at the table. It's a principle. Look at the table. The first one you find, oxidized. The second one you find, reduced. So when we compared this one, this was on top. So copper is oxidized. When we come here, they are both copper. You're not comparing anything. It's just copper. So therefore, here, you need to write it down. You cannot reduce a solid. You cannot reduce a solid. That's a very, very important information. You can never reduce a solid. Right? Solid cannot be. Every time you say reduction, it's always an ion. Is that okay? Lovely. Can I continue now? All right. The net ionic equation, do you know how to write that? Huh? Check. We'll write the anode and the cathode. What happened at the anode? Cu, Cu2 plus what? 2E. What happened at the cathode? Cu2 plus 2E. What I need to check is my electrons. What do you notice? I have 2 here. I have 2 here. It means it's balanced. If it's not balanced, we multiply. Everyone should have done that. Now, what do I write? I write whatever I see on the left. Cu solid, Cu2 plus. I write what I see on the right. 3 marks. That's 3 marks. But that's not where I'm going on this. That's not the main thing. That's not where I'm going. This is where I'm now going. What happens to the electrolyte? Concentration remains the same. And what would that tell me? The degree of blueness will not change. You will understand just now. Will not change. Remember, what did we say? Copper 2 plus is what? Blue in color. So if that is not changing in number, it means the blue will not fade away. How do I know that is not changing? Please look at this. At the anode, what am I forming? Cu2 plus. So Cu2 plus is going into the solution. At the cathode, what is leaving the solution? Cu2 plus. It's like having 2 doors in class. One person leaves and another person enters. What happens to the number of learners in class? That's exactly what's going on. So at the cathode, I'm losing Cu2 plus to Cu. But at the anode, Cu is becoming what? Cu2. So whatever is lost here is gained back. So the number of Cu2 plus ions will remain what? The same. Hence, the concentration remains the same. It means the blue color will not change. Make sense? All right. That's an application question there. We have 8 minutes on the score. But I'll get you, don't worry, everybody. I'll get you if you are on this. It's Meleng. Just shout when it's 3 minutes. To me? Sitley, my timekeeper is not in. To me, you got me? Aibo. To Meleng. Or Chris. All right. Divine says, what happens to the Cl? It remains as a spectator ion. The chloride ions is still there in the solution. It's not changing. It remains as what? Spectator ion. And how would I know that it's a spectator ion? The oxidation number will not change. Ooh, I wish I'm an examiner. Oxidation number remains the same. I hope you can define in terms of oxidation number. Oxidation and reduction. Oxidation is an increase in oxidation number. Reduction is a decrease. If I'm an examiner, these hidden things are the things I'd like to ask. Yeah. But I'm not. Next. If I promise you, these are the little things. I want to test if you are listening in class. No. It will not always be. That's why you don't cram this thing. You look at the process and go along with the process. All right. This is using copper what? Electrodes. Let's change the electrodes to carbon and see what happens. Once we're done with that, we answer our question. I've spoken more than enough. I've said more than enough. Huh? I've said more than enough. You need to watch this again. All right. B. If I use carbon electrodes, what's going to happen? Will there be a difference? Okay. Check again. What do we have? We have that. We have that. T, T, ta, 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 T, T, ta. Carbon and carbon. Are we good? Oh, I forgot something. Huh? Can I quickly deal with what I forgot? It flashed my mind, and it flashed my mind again. Let me go back. When we talk about electroplating, if I want to electroplate something that is not a metal, all right, just going to put it in a bubble. To electroplate a non-metal, first coat with graphite. First coat with graphite, which is carbon. Graphite is the same as carbon. Because you need your electrodes to be conductors of electricity. That's where the word comes from, electric rod. So they must be. So if I want to electroplate a shoe, I just bumped into Mandela's shoe and I want to preserve it. All right? It's not a metal. What do? I coat it first with graphite, which is what? Carbon. All right? Now it becomes, because carbon is a semiconductor. It can act as both what? A metal and a non-metal. Please remind me 2 minutes. I want to send the link right on this group chat so we all click at once and then we go. Or 3 minutes. Once it's 3 minutes, let me see my time. It's 3 minutes. Okay. I'm just going to send the link right now on this so that we all just click it and you move to the next link. I just need to sort out a few things on my links. All right, I just sent you a new link. You can start exiting this. Click that link. It takes you to the next one quickly. Exit quickly. I'm already on the other link. Some of you are still here. I'm out of here, guys. It's on your group chat, Divine. It's on the group chat. Right here in this platform. Just click the link and exit the old one. It's right here. Oh, they won't even hear me because I'm out. MFI, not VI. All right, everybody. These guys are still here. Somebody's still asking for LO paper. Eh, done now. Okay, we are back. Let me just see if the guys that need this link quickly. One second, guys, just to make sure everyone is here. It's working, just my battery. There's one hand I need to fix there. It works. Yeah, there's just that it works perfectly. The prop, I don't know, it probably fell down somewhere. Probably fell. So it's methyl clock, ethyl clock, propyl clock, butyl clock, exo clock, da 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 da. All right. Okay. I think everyone is in. We can continue. Now, what happens here? We're still going to have. Ooh, where are you going? We're still going to have what? Copper chloride. Is that fine? So we have copper chloride. Remember, positive and what? Negative. This is the anode and that's the cathode. This thing is going to break down to what? Cu2 plus, Cl minus. Where will the Cu2 plus go to? To the cathode. Where will the Cl minus go to? So what do we have here? We have carbon and chloride, ions. What do we have here? Carbon and copper 2 plus. We're good. Okay. Remember, we're looking at oxidation here. And here we're looking at what? Reduction. Here's my question. Which one will be oxidized? We are now comparing carbon and chloride what? Ions. The one we see on top. Let's go to our table. We are looking for what? Carbon and... All right. Carbon. Don't let me waste my time. There's no carbon on this table. You can, yeah, there's no carbon. Don't let me waste time. I normally punish you guys. I normally punish learners. They check like 3 times. Maybe they are missing something. There's no carbon there. All right, so we ignore carbon. Is that okay? And focus only on what? Cl minus. So there's no need to check. Which one will be oxidized? Cl minus. Because there's no carbon. It's inert. All right? So at the anode, what are we going to have? Remember, you write going where? Backwards. What would it be? 2Cl minus to give us what? Cl2 plus. Remember, this is what? A gas. Green bubbles. What are you going to see at the cathode? Remember? Copy, cat. Again, this guy is not there. What are we left with? Cu2 plus. What will it be? Cu2 plus 2E to give us what? Cu. All right, my beautiful learners. What would be my ionic? My electrons are also balanced. 2, 2Cl minus plus Cu2 plus Cl2 gas. Another 3 marks. Finally, on this, and I can go to the question and we answer it and deal with the stoichiometry, is what happens to the concentration of the electrolyte? Please check again. What's happening at the anode? Our Cl ions are being converted to what? Cl2 gas. What's happening at the cathode? Our Cu2 plus is being converted to what? Cu. Do you notice we are losing Cu, but we're not getting it back? As compared to, okay, stop, let's check. Do you notice here, come back to this equation. Cu2 plus is converted to what? Cu. We're losing it here. What's happening here? We're gaining it back. Because Cu2 plus is formed, Cu2 plus is lost. One person is leaving the class, we lose one person, we gain one person, the number of learners in class remains what? The same. But come back here. What's going on here? We are losing this. But we're not getting it back. Do you know why we're not getting it back? The reason we were getting it back was because the electrode here was copper. It was replacing what was lost. Now, this is not copper, it is carbon. There's no source of replacement. So what's happening to the number of copper ions, electrolyte? Decreases. The concentration of Cu2 plus does what? Decreases. Because it is lost to what? Reduction. And it's not coming back. Because we don't have a source to replace it. What then happens? Color changes from what? Blue to light blue and may become colorless at the end. Because copper 2 plus that is responsible for the blue color of the solution is being lost. In the first one, it was lost and replaced. In this one, it is lost without replacement. I think we can answer the question now. I said I was going to talk for 5 minutes.
That's 5 minutes.
Yeah, it's 5 minutes over now, right? Yeah. 5 minutes is over now. But with this, we're going to just flow. On that electrolytic. Flow, flow, flow. Please get your marks. It's 30 marks. You would see I've actually mentioned almost everything. Almost everything. Can we answer? Check. What are we doing now with this question? Electroplating is an electrolytic process that can be used to what? Coat metals object with a less reactive metal. Why less reactive? To protect it from rust. I gave you that reason. All right. The diagram below shows an electroplating cell that includes a power source. What type of power source? AC or DC? DC. Why DC? To maintain polarity. Okay. Power source connected to a copper rod. Okay, let's take note. A copper rod and a bracelet made from a different metal solution. The rod and bracelet are in aqueous cup. Please, let's take note. What's happening? Which rod? Where was the first rod mentioned? All right. Connected to a copper rod. What is the solution? It means if I lose the copper, I will gain it back. Because there's a source of replacement there. There's an ATM there. Imagine you're shopping and there's an ATM following you. Shop 2,000 minus plus 2,000. What happens to the amount? You wouldn't you life will be sweet, ne? You can just shop anything. All right. Remember, this is what? DC. Where do we see? At A or C? We see at C. So what's happening here? This one is my cathode. And this one is my... What's going to happen to the size of the bracelet? It's going to increase. All right? Get fat. Why? Gaining. All right? Always eating. What about the anode? Decrease in size. Did we define this? Ionic solution that conducts what? Electricity to the process of... to the movement of ion. Did we answer this? What is the answer? Which electrode, the bracelet or the copper, is the cathode? Can you see that we're moving now? The notes actually gives you all the answers. 4 marks, just like that. All right? Initially, what do you notice? The copper sulfate has a blue color. Why is it blue? Because of what? copper. Now check. How will the intensity of the blue color change while the cell is functioning? Give a reason for your answer. The rate of oxidation is equal to the rate of reduction. The only thing I would like you to mention is what is oxidized and what is reduced. The rate of reduction of Cu2 plus is equal, let's put the word rate, is equal to the rate of oxidation of what? Cu. 2 marks. Write down the half reaction that takes place at the pure electrode. At the pure copper. Wait, the pure copper one is what? There? We said it's the anode, right? Because the bracelet is the cathode. What are we doing? Writing A is writing from the right to the left. What's your answer? Cu to give us what? Cu2 plus. We're done. Now we left with 6 marks. Are we okay so far? All the answers, there's not, it's about a copy and paste situation right now. Copy, paste, copy, paste. Please don't go with this note to exam hall on Monday. You try not to. Imagine you have this note, you just. I'm going to call teachers and principals. All right. Guys, the whole of last year, all prelim papers had number 5. All of them. I've only seen one this year. I wish I had others. I wish I had Free State. But I've only seen one this year. And the fact that it's coming back, I see that it might come back. Even the final had stoichiometry, and it's very simple. It's 6 marks that I want you to get. And please listen. Stoichiometry deals with number of moles. That's what it deals with. You hate it. As I'm doing this, I'm already dealing with acid and base. Please. Stoichio. I'm already dealing with acid and base. Stoichio. All right, I'll try not to take long on this one. Everything stays around what? Number of moles. What can I get from number of moles, my dear learners? N equals to what? Number of particles over Avogadro's constant. Please, this is number of particles. Number of particles. And one of the particles that we know is what? Electrons. An electron is a particle. Ions are particles. Cations are particles. So all of them go into that. What else? Number of moles is mass over molar mass. What's next? N equals to volume over molar volume. Next one. C equals to what? N over V, which means N equals to what? There's nothing you want to calculate in chemistry that is not here. Because these are the things you calculate. Mass, volume. These are all. All right? So what is the secret? I've always used this secret and it has worked for me. Anything they want me to calculate, check here. A plus B. The reason why you see 6 marks, 5 marks, anything more than 3 would follow this principle. Okay, I'll just use a case study here. Find the mass of A. For me to find mass, what do I need? Number of moles. Because the molar mass of A I'll get from the periodic table. But I will not have the number of what? Moles. Please check here. They will not give you that number of moles. If they give you, it's 3 marks. Because if they give you the number of moles, what do? You look for the molar mass, cross multiply, and you're done. That's not 8 marks. That's 3 marks. So they will not give you that number of moles. But they'll give you an information either on B, C, or D. What is your first step in stoichiometry? find the number of moles that reacted or produced. I teach this from grade 10, the exact same way. So you check, what information do I have? Do I have that of B? Do I have that of C? Do I have that of D? If it is B, it will be reacted. If it is C or D, it will be produced. All right. If it is product, it will be produced, right? If it is a reactant, it is what? Reacted. But please check, what am I looking for? Number of moles that reacted. Not excess, not what is left. That reacted. Number 2, use mole ratio to transfer the moles. Use mole ratio to transfer what? Moles. So for example, I get mole of C, then I'll say A to C, right? 1 to 2. What am I doing? Transferring the number of moles of C to A. What was missing before? The number of moles of A. Now I have it. I don't know if it makes sense. And then number 3, calculate what is needed. And we are going to apply these 3 processes now to this question. And then we run again to galvanic. And then we do rates. If you can get those 3. If you can get those 3 questions done. I mean, you guys are tired from paper 1. Still mentally tired. Some of you did not sleep last night. Okay. Please let the questions come in. If you have questions, let it come in and whatnot. Okay. Can we answer? Ready to answer? Let's see what the examiner is saying here. During the process, the bracelet is plated with what? 0.86 grams of copper. Calculate the number of electrons. Let's pause there. What is that symbol? It's the capital N. But where is that connected to? Avogadro. Wait, if they give us the number of moles here, don't you see that we are done? But what did they give us? They said it's plated with what? 0. So they're giving us copper as our point of reference. All we need to do is to calculate the number of copper of moles that was what? Plated. Use mole ratio. We are done here. Check this 6 marks. It's as if you are writing your name. 6 marks. What happens at the cathode? Let's start by writing the equation. We wrote the equation at the cathode. What was it? Copper 2 plus what? 2E to give us what? What did the examiner give us? Remember, hold on, let me give you the flow. I'm looking for N, right? So N equals to what? N over what? Na. If I can get the number of moles of electron, I'll be fine. But what did I say? They will not give you. What do you need to do? Step 1, find the number of moles that was produced or reacted. Do we have number of moles produced? Yes. We can get that from what? Copper. So what is the number of moles of copper? Mass over molar mass. What was the 0, 6? Do we know the molar mass of copper? If you check your 63,5. So it's like you have it in your head. Copper, you've done it so much, you know it. You are fighting with it. Shame. Don't worry, you will destroy it on Monday. What is the number of moles of copper? Get me an answer. Let's get the 6 marks quickly. If you are still busy with the calculation, make it 4 decimal places. 0,0135. Don't round off quickly. Is that okay? 0, comma? Is there a 0 there? 0, 1, 3, 5. All right. I like to do this. Moles of copper. I want to tell the examiner I know my story. Step 1 is done. Number of moles produced. What is step 2? Mole ratio. What am I dealing with? Electrons and copper. Come here. Electrons. Electrons. And what? Give me the mole ratio. 2 is to 1. Do you see where my 2 came from? All right. But do I know the number of moles of copper? Yes. Do I know the number of moles of electron? No. What do? Cross multiply. So what is the number of moles of the electron? 0,027 moles. Oh, by the way, so N equals to what? N over Na. 0,027 equals to N over. That's a constant. 6,02 times 10 to the power what? 23. What do? Cross multiply. 6 marks on the back. Done. Just like that. 6 marks. Just like that. 6,02 times 10 to the power 23 times 0,027. What's your answer? Confirm. Is it correct? 1,6. Now we can do 2 decimal places, right? 1,63 times 10 to the power what? 22 electrons. Please, if you understand what I did here, acid and base becomes very interesting to do. That thing of 8 marks. That thing of 8 marks, 9 marks, 10 marks. Ooh, I just get happy when I see it. Because it's cheap. Check. Look at all of this for 6 marks. How many lines? Let's mark it. 1, 2, 3, 4, 5, and 6. Eh? They can increase the number of marks now. Full. Why would you get 2 marks? But after now. No, 6 marks. All right, let's look at this. Let us look at this now. What is this? A galvanic cell, right? What do we know? This is exothermic, chemical to electrical. Basically the opposite of what we did. No, this one, we're not going to, because we are producing electricity, we're not going to talk about whether AC or DC here. All right. What you need to know is which one is, look, identify your anode and cathode. You're looking at what I'm looking at. No, don't worry. I'm fine. I'm not even seeing things that are here. I've mentioned a few ways of identifying anode and cathode. Number 1, the movement of electrons. Is that fine? Electrons will move from where? Anode to cathode. I don't want to talk for long here. No, I'm not going to talk for long. I promise you. Give me 7 or less. Because most of the points are the same. Just going to point out the differences. Conversion. Chemical to electrical what? Energy. What else can you tell me? It is exothermic, right? This must happen under standard what? Conditions. What are your standard conditions? Temperature of 25 degrees Celsius or 293 Kelvin. Concentration. What's the concentration? 1 mole per cubic decimeter. Gas. Pressure when there's a gas, right? Pressure when there's a gas of 1 atmosphere. Only for gases. Standard conditions. When do I use platinum? Platinum is used as an electrode. Is used as an electrode. The question is when and why. When and why. Let's answer this too. When do we use platinum? And why? When I have a gas involved in one of my half cells. And number 2. Thank you for giving me the why. Love that. Thank you, sir, for giving me the why. Why? Because it's a solid. There are 3 of them. It's a conductor. All right. And it is inert. What's the second one? When we have non-conducting substances. Non-conducting substances. So every time I see a gas, I know that I have to bring in what? Platinum. Platinum is used as an electrode. There's an important component here. Salt bridge. Want to tell me about it? What can you tell me? Huh? Talk to me. All right. Number 1, it completes the circuit. That's the common one that everybody knows. And if I'm an examiner, I'll tell you, apart from completing the circuit, A, it's like acid and base. My question would be, apart from water, write another ampholyte. Then I finished you. Because if I were to give you an example of an ampholyte, everybody just says water. I once did that in an exam, and Lena wrote, apart from water, I said H2O. Yeah, like Lena was for real, like, yeah. Hi, Chris.
Now, say something about your mic. I couldn't hear you.
Oh, can you hear me now, though?
Yeah.
All right. Completes the circuit and maintains electrical neutrality of the half cells. Question is, how? No. Okay. How? The anions will move to the anode. We spoke about this. And the cations in the half cell or in the salt bridge will move to the what? To the cathode. So sometimes for us to identify the anode and cathode, they will draw those ions moving. The anions will always move to there. I'll show you when I look at that diagram. Anions will move to the anode and cations will move to the cathode. The salt bridge contains a high concentration of an inert. High concentration, in case an examiner wants to ask, of an, let's say ionic solution. Please don't use chloride. This is where it's very important. Don't use chloride at all. Like, you can only use chloride if the half cell contains chlorides, because we are going to form a precipitate somewhere if we are not careful. Okay, so anions will move towards the anode, cations will move towards the anode. We're done there. Cell notation. Do we know how to write the cell notation? It's as simple as ABC. Thank you. We start from the anode, we go to the salt bridge, and we then write what? What happens at the cathode? How do we represent the salt bridge? Guys, what is this single stroke representing? When do we use it? They will ask you, what's the purpose? This is for a phase change. That is, if I have a solid and an aqueous, I'll put it there. I'm going to do an example here. That will not require that. Okay. Thank you to me. Phase change. Lovely. I'm tired of talking. Can we answer? A learner wants to investigate the effect of the area of the metal plate. 7 minutes. Perfect. Used as electrodes in the galvanic cell on the EMF. Wait, what are we comparing? The effect of, remind me, if this question doesn't handle it, I want to tell you about how EMF changes. The things that will affect your EMF. Because it's Le Chatelier's principle. Sorry. All right. The learner sets up the following. Under what conditions? Standard. Did we mention the standard conditions? Yep. Remember? Which electrode will show an increase in mass? Which one? Is it the cathode or the anode? The cathode, right? Can you identify the cathode for me? Which table are we using? 4B. Which one? Is it the first or the second one? All right, quickly, everybody, I'm sure you have a table there with you. You have a table. Quickly. Which one? Are you sure? Can I get answers from you guys? Remember, the first one you find. So which one? 4B. Is it zinc or lead? What did you say? Platinum is PT. Huh? Where is zinc? So zinc is the first one we find, right? So zinc becomes the anode. And lead becomes the... Please, it's important to fix this. Now, check, before I move to the other questions, look at what the examiners will do for you. Please, I want you to notice. An examiner can come and tell you, electrons are flowing this way. They won't give you zinc, they won't give you lead. We'll use electrons to check. Number 2, check. Examiners would come here and say the negative ions are going this way and the positive ions are going this way. I don't know if it makes sense. We said the positive ions are called what? Cat ions. Where will they go to? The cathode. The anions will move to there. So once I see that, I already know what's going on. I know the cathode and I know the anode. What else will they tell me? Increase in size. Increase in size. And this one will what? Decrease. So all of this is just defining anode and cathode. Wait. Go back to the word ape. Do you remember what we said ape means? What did we say? The anode is positive in the electrolytic. You know what it means here? The anode will be negative. Row changes. So this becomes what? The negative. How will they show me? They'll put a minus here. And they'll put what? And it makes sense. Can I tell you the sense it makes? Electrons are what? Negatively charged. Where do they move to? Unlike charges will do what? Attract. So the electrons are going to the positive end of the battery. All right, so this is negative and that. So these are possible ways of the examiner trying to ask you which one is the anode and cathode. All right. What's our answer? Let's answer now. I'm tired of talking. Cathode is what? They said which electrode? PB. Everybody agree with me? That's the cathode. Wait, Tumeleng and Tumi, are we okay? Because you're giving me zinc.
Evening, sir.
Hi, Tumi.
So you asked which one was oxidized. That's why we said it.
Oh, okay, all right. As long as we are on the same page. All right. Write down the half reaction that occurs at the anode. Are you doing that for me quickly? Give me those 2 marks. Anode. A and C, remember? If you use your A and C method, it works perfectly all the time. It has never failed me once. It's the reverse, right?
Yes.
Where is it? Zinc and lead. You know what I do with my page? I'll do this. Zinc and lead. All right, so this is what I have. So if I were to write the letter Z, I don't know if it makes sense. So you can do that in your paper. That shows you which one is going where. So what's my answer? Let's write it. Shall we confirm? 8.2 would be what? Zinc to give me what? Zinc 2 plus. Number 3, please calculate the EMF. EMF, do we know how to do that? With just plug, give me the value on your table there for zinc. Negative 0.76. What about lead? All right, everybody, please get me that. 4 marks. Quickly, get me the 4 marks. You know the formula. EMF equals to what? E cathode minus E anode. Free 4 marks there. Calculate. What are you waiting for? Use your phone. You're proud of the 4 marks that, oh yeah, this one. And if they give you the EMF and ask you to identify, it's 5 marks. Because they can give you the EMF and ask you to identify the metal. Everyone should be done with this 4 marks. It's the easiest 4 marks. EMF equals to what? E. Please don't write cat. You'd get it wrong. It's not cat. All right, which one is the cathode? Negative 0.13 minus negative 0.76. What is your answer? 0.63 volts. No volts, you lose the mark. Careless mark. That would be a very careless mark to lose. Name two variables that should be controlled during this investigation. Your standard conditions. Temperature should be controlled. No, there's not pressure because there's no gas. Concentration. Temperature and concentration should be controlled. Please interpret it. I've seen that question. All right, so we need to keep, this is basically asking for what? Standard conditions. So in this case, only what? Temperature and concentration. Gas is not involved. Why is gas not involved? Sorry, pressure is not there. Why? No gas. Okay, we're good. Please remind me. Factors that affect EMF. Please, very important. Okay, let's check. The learners now replace the two metals with one of a larger surface area. All right. And takes the voltmeter reading again. How will this affect the EMF? All right, this is one of the factors. I'll quickly help you with this one. It will increase. And I'll tell you why. Larger than. Explain why. A larger surface area. Let's quickly talk about factors that now affect what? Factors that affect EMF. Let's talk about it here. Oh, this one I don't promise you I won't talk less. Factors that affect EMF. Number one, the size of the electrode, which is the answer to this one, right? More electrons flow. I don't know if that makes sense. If the surface area increases, more electrons are available. More electrons are moving. All right? More electrons flow from the anode to the cathode. What happens? The EMF increases. Do you know why the EMF increases? If I say more electrons, it means current is going to increase. And according to Ohm's law, more current, more voltage. But basically, I'll use something else. EMF increases because more work is done. More work is done per unit what? Charge. I'm using definition. Ooh, that's 15 minutes. More work is done per unit. I don't know if it makes sense. More electrons are flowing. What is EMF? The examiner is checking if you know the meaning of EMF. You need what? What is EMF or what is voltage? It is the work done per unit what? Charge. Now there are more electrons. They asked you today. All right. More work is done per unit charge. So if the number of charges increase, it means more work will also be done. Are we okay here? I'm done with this question. I'm done. We've answered. You get 2 marks there. But what are the other factors? Number 2. Let's look at concentration. How will concentration... My dear learners, I need you to listen to me on this one. We are going to use Le Chatelier's principle. Le Chatelier's what? Check here. First, let's do this. I won't take you... I don't want to go into so much detail. E what? Cathode. Minus E what? Anode. Check this. The electrode, I'm just going to write one statement. The electrode potential value, increases as concentration increases. So you will get something like the concentration of the anode was increased. What will happen to the EMF? This is your first approach. The electrode potential value increases as what? Concentration increases. Now check this. E cathode minus E anode equals to the EMF. Let's do a bit of maths. If I increase this one and keep anode constant, what do you think will happen to EMF? Just do basic maths. 10 minus 4 equals to 6. Let's increase this to 12. Keep this one constant. What happens here? That one increases. Make sense? If this one decreases, what happens to this guy? If this one increases, come, let's do a bit of maths. 12 minus 4 is 8. What if I increase the 4 to 6? What happens there? What happens to my answer? Decreases. And if this one decreases, what happens to EMF value? I don't know if it makes sense. Just use your numbers. Use numbers. Yes, Chris, factors that affect EMF. Can I move on? Number 3. Oh, still on concentration. Contamination. Quickly, let's be fast on that. Then I'll look at temperature. Contamination. I'll show you just 1 second. The formation, I'll show you just now, formation of precipitate. And what are the precipitates I'm looking for? The common one. Silver, mercury, although you won't get that, and lead chloride. Reduces concentration. So you need to check where that is formed. Is that formed at the anode or at the cathode? They will tell you that they put sodium somewhere there, or sodium chloride. So if they have silver, maybe silver in the anode or the cathode, right? You identify that silver is the anode. And you have, so what they will do is they tell you that we now put sodium chloride in the anode. Wait, there's sodium chloride, there's silver. What am I going to form? Silver chloride. Once I form that silver chloride, it's a precipitate. Wherever that forms, the concentration of that cell will do what? Decrease. And when that decreases, you come back to my table here and sort it out. We are done here. Temperature. That's my key. Let's look at temperature. All right, guys, quickly write this. Write this. All right, let me answer this one. Oh, by the way, let me talk about temperature, then we go back and check if there's any questions still remaining. Why will temperature affect? Let's check something here. A plus B to give us what? C plus D. What did we say about these reactions? These reactions are exothermic. Okay. Delta H is what? Less than 0. If we increase temperature, what happens? Which reaction is favored? The endothermic is favored. Endothermic is favored. Which one is the endothermic in this case? The reverse. I don't know if that makes sense. The Churchill's principle. Remember, we are saying this is exo always. Therefore, this will be what? Endo. So if I increase temperature, endo is favored, the reverse is favored. Anytime your reverse is favored, EMF decreases. If we decrease temperature, these are some good notes that I'm giving you. If we decrease temperature, what happens? The exothermic is favored. Forward reaction is favored. And what happens? EMF will do what? Increase. All right, lovely. I've already answered the question we were answering, so this is just elaborate to deal with other questions. After this, we answer rate of reaction, and then, yeah, we will be good. We will be good. Please tell me again when, okay, I'll check. I'll keep checking my time. We just do the exact same thing. Sir, what is a precipitate? A precipitate is a solid that is formed when you have two aqueous solutions. A precipitate is an insoluble solid that is formed. An insoluble solid that is formed when you mix two aqueous solutions together. You can just Google a picture of that. All right, let's answer and then move to rate. So we agree I've answered 8.5.1 and 8.5.2, right? The increase in the plates makes more electrons available. More work is done, the flow. The learner now connects a low resistance across terminals A and B. Ooh. The learner noticed that the reading on the volt... you know what they're asking here? Internal resistance. Yeah, they're bringing in physics, what you did today. The learner connects a resistor of low resistance. All right, A and B. The learner notices the reading on the voltmeter. Do you remember? Once you complete the circuit, what happens? EMF drops. Due to what? Lost volts. Because of an extra what? Resistance that we have. I don't know if that makes sense. Okay, let's go back to physics quickly. If I have this, let's keep the switch open. What am I going to measure here? EMF. Right? Why EMF? There's no current flowing at the moment. All right? And since there's no current flowing, we measure the maximum. Once I close this guy kicks in. Do you notice the total resistance of the circuit has increased? Make sense? It means we're going to have what you call what? Lost volts. And the EMF will do what? Decrease. Because voltage is lost due to the internal resistance. I'm done. Give a reason for this observation. By the way, guys, please don't forget that this whole thing is a battery. It's a cell. It's a galvanic cell. So whatever you did under Ohm's law comes in here. So what happens? Internal what? Resistance. After some time, the learner observes a further gradual drop in the reading on the voltmeter. Give a reason for this reaction. What's happening? Here is, we are approaching, this is called, the rate of reaction. Rate of reaction. Yes, Tina. Oh, I have 3 minutes. Guys, let's quickly change. Yes, thank you, Tina. This is going to be the last link for the day. Please move to the new, let's move to the new link, the last link for the day. I'm waiting for you all to move. The link is on the chat box, just click it. Guys, I'm waiting for you to move. The link is right in the message chat. Please move quickly. All right, you guys will find me on the flip side if you're still here. Gracia and Jabulo, Itumeleng, you guys are still here. See you on the flip side. I have sent the link. Okay, let's see if we are good to go now. All right, are we good to go? Can you hear me? Somebody please confirm. Thank you to me. All right, so we were saying that after some time, thank you, sir. After some time, the learner observes a further gradual drop. Now, what happens? Why are we experiencing a further gradual drop? Okay, what happens? What's your answer here? The answer is because you are nearing what? Completion. Is that okay? We are nearing what you call chemical equilibrium. We are moving close. As we moved close to chemical equilibrium, what happens? The rate of forward reaction will be equal to the rate of the reverse. At that point, the EMF becomes what? Zero. So why are we, but I want to answer this very nicely here. Why are we noticing this? The number of electrons transferred is now decreasing. Number of electrons transferred decreases. Please take note of that. The number of, something is wrong. They said voltmeter. What should we say? Number of electrons transferred per unit time decreases. And this will continue until you get to a point where you call a flat cell. Let me put a flat cell note here. Flat cell, EMF becomes what? Zero. Why? We have reached a state of chemical equilibrium. Awesome. Please, 30 marks so far, done. More than 30 marks. You should be able to answer any question. But I want to deal with one before I move to rate. I told you guys to remind me of something which you didn't. So I'll create a question. Don't worry, I remember. So I'll create my own question now. Okay. I want to create a question quickly for us just to make sure that we are all on board. Look at this. And I haven't seen this question before, so I'm just going to create it for us to be able to work. Let me use a gas. Let me use a gas on one side. And let me use iron 2 plus and iron 3 plus. And then I'll have, beautiful, that's exactly what I need. Let's use a gas, that. And I have hydrogen gas. Okay, good. Good one. Good one. You can see it. Which one is the anode and which one is the cathode? If you get that right, then we're done. Now, if you check here, please look at what I'm going to go look for. Hydrogen, therefore, definitely is the 0 one, right? What am I going to look for here? I'm going to look for an equation that has Fe2 plus and Fe3 plus. There are 3 Fe's on your table. I'm going to take you through that table very quickly. 3 Fe's on the table. Please follow as I take you through. I'm going to make it very big so that everyone can see. All right. Li, are you seeing that right? Going down. Okay, especially those of you at home. All right, this is what I'll do. Check here, Li to zinc. Is there any Fe there? No. I'm going to move now below zinc or from zinc to Cu. All right, check. Is there Fe here?
Yes.
In fact, here there are 2 Fe's. I don't know if you see. Fe2 plus and Fe. Is that the one I want? No. I want Fe3 plus and Fe2 plus. Let's look at the bottom. If we move down, what do we have? Fe3 plus and Fe. Is that the one I want? No. I have to go down more. Where is the third one? Oh, guys, look at the bottom here. Fe3 plus and Fe2 plus. That's the one I'm looking for. So if the examiner gives me copper 1, if I go check copper as well, you will find. Look at the copper we have here. I wish I could highlight this. It's because I didn't convert this thing. But if you check right here, you would see Cu2 plus and Cu. Right? Right above it, what do you see? Cu2 plus and C plus. That's copper 2 and copper 1. So look at the question carefully. The examiner will always guide you to which one to use. So which one are we using? Fe3 plus and Fe2 plus. What are we comparing it with? Hydrogen. Oh yes. I think both of them are here. This is my 4B table. Which one do we find first? It's right there, guys. Why are you searching again? Hydrogen is the one you find first. It's actually bounded, the one on top and the one at the bottom. Hydrogen on top, Fe3 plus 2 plus at the bottom. Make sense? So which one is oxidized? The top. Which one is reduced? Beautiful. So what do we know now? What do we know? Anode and what? Can I ask you to write? I want to do 3 things quickly. Write down the half reactions at the cathode and at the anode. Quickly, everybody. Write down your half reactions. To me, it's not Fe. We don't have Fe here. Right? We do not have Fe. And guys, before you answer what is oxidized or reduced, please write the half reactions. Write the half reactions, anode and cathode, quickly. Use your Z. If you use the Z, the answer just pops out. Because it's just going in that direction. Jacob Zuma. I used to tell people that Jacob Zuma was my chemistry teacher. Why are you giving me a bombastic side eye? The president himself taught me chemistry. Well, you know you have an option not to believe and to believe. But I'm telling you the story of my life. All right, do you want to give me your answer? Hydrogen gas. We go backwards, right? So what's happening at the anode? Anode. What do we have? H2. We have the arrow. What do we have? 2H plus. Plus what? 2E. What about the cathode? What do we have? Fe3 plus. Plus E. To give us what? Fe2 plus. We okay? Now balance. Write the net ionic equation. Net ionic equation. Please write the net ionic equation. I'll suggest probably after resting today, just for, you can watch this lesson again and answer the same questions. Look for another paper, quickly answer this. We'll do rates now. You answer those 3. You know that, okay. 24. Don't worry. I want to see if I could actually do organic reactions. That takes about 10 minutes. You don't believe me? Too easy, that one. And that's the one you guys struggle with, right? And it's the easiest. You wonder if I'm living on this planet. Okay, are we done? What do we do? If we move fast here, we can. Multiply this by what? Remember there's a 1 here. So multiply this by 1 and multiply this by 2. So what's going to be our net? I'm just going to jump to the answer, everybody. Once I do that multiplication, there is no need for me to write the electrons anymore. Multiply that 1, what do I have? H2, can I go down now? 2Fe3 plus, that's what's on the left. I've multiplied by 2. What about the right? 2H plus plus 2Fe 2 plus. I have my 3 marks there. Please write for me the cell notation. Cell notation. And once we write that, we're done. We're moving on. Cell notation. It's as simple as ABC. What's wrong? This one is difficult. Cell notation. What do? Start with the anode, right? So what do we have on the anode? H2. Don't be scared. Gas. What's next? H plus, which is what? Are we fine there?
Yes.
Okay. Don't be scared. All right. Phase change there. So what do we use? I'm going to tell you something very important here now. We're done with the anode, but not done. Salt bridge. What do we have on the cathode? Fe 3 plus, which is what? Aqueous. Next, Fe 2 plus, which is what? Do I need a phase change here? Do you notice they are both aqueous? However, please, the end of your cell notation must always be solids. Always. This is why, look at, let me add this before I forget. Let me add it. Go back to your notes. When and why. Number 3, when I have a mixture of ions. When do we use platinum? When I have a mixture of ions. Now, do you notice here I do have a mixture of ions? That's why this electrode, I purposely did not write the electrodes. What happened? Okay, this one should have been here. This is platinum. Why platinum? Because I have a gas. Here, what is this electrode? Platinum. Why? Mixture of ions. So I need to come here and say platinum, which is what? A solid. And then at the end as well, platinum, which is a solid. Okay, I'm done. What should I? Can I look at organic reactions quickly? The one that you said is difficult. Rate, I think you can answer rate for now. You should try. Organic reactions. So guys, I hope you learned 1 or 2 things there. Let's see, organic reactions, so that you have time to go through and assimilate this. Organic reactions. All right. If you have ever listened to me teach organic reactions, my dear learners, this is what I always do, and it has always worked for me. Organic reactions. I'm going to talk to you for 7 minutes. Time starts now, right? Good. It is SSSSUEUSA. You know what that means? Soup. Saturated to saturated substitution. Saturated to unsaturated elimination. Unsaturated to saturated addition. I told you it's very simple. That's the first. That's the first one. I'm only going to talk about three things. You need to know these acronyms. CEDS. When I use a concentrated strong acid or base, I will be eliminating. And when I eliminate, one thing that is needed is strong heat. But when I move to dilute strong acid or base, usually the base, I will be substituting. These are the reaction what? Conditions. And this one is mild what? Heat. Mild heat. Mild heat. Then I have a list of catalysts that you need to know. Number one. Okay, if I'm talking about esterification, let's quickly list it. Esterification, I'll be dealing with what? Concentrated sulfuric what? Acid. Number two, let me just try to list something here. Hydrogenation. Number three, halogenation. Number four, I'll write the catalyst. Hydration. Number five, if I remember any, I'll let you know. Huh? Nah. These are the main ones. All right. Hydrogenation. Let me just quickly make sure I give you the right thing. But once you know this, I'm going to apply this now quickly. You would see how we're going to get, and you must know your what? Markovnikov's rule. What? What do you mean? Who? All right, okay. Hydrogenation, we use platinum or nickel. Halogenation, we use UV light. Hydration, we use phosphoric acid. There's one that has no water. I think it's hydrohalogenation. Hydrohalogenation. This one is there must be no water. No water. No water. All right. Okay, guys, if you know this, look, you will be okay. I might be forgetting one or two things, but can we apply this quickly? We're good. We ready to apply? How would I do my question? All right. Various organic reactions are shown in the diagram below. Are you with me? Please check. Your job is to quickly identify which one is saturated, which one is not saturated. Look, alcohols are considered as saturated. Take note. I'm not saying they are hydrocarbons. Hydrocarbons are organic compounds with hydrogen and carbon atoms only. Hydrocarbon. But anytime I see alcohol, I'm going to consider it as what? Saturated. Check here. I have saturated. What about this? It's another saturated. Why? Already I know what B is. What is B? Sub. Does that make sense? Good. What is C? Oh, another what? Saturated. What is that? Sub. Plus heat. Oh, I see sulfuric what? Acid. So what's happening here? I know I'm going to form an ester. What is this process? Esterification. Okay, my beautiful learners, check. This saturated, I'm coming down to D. What do you notice? A strong base. But they said what? Concentrated. CEDS. What is it going to be? Elimination. Because I have consent. Can you see heat reflux? Okay. When do I use UV light? Talk to me. UV light? Is it hydrogenation or halogenation? Halogen. Can you see? What is this? It's a halogen. So what is this? Halogenation. By the way, X. Wait, do you notice? Please check. I am moving from something X to a saturated compound. It is either going to be an addition or a substitution. I cannot have elimination. Right? If you check, which one ends in saturated? It is either substitution or addition. Okay. But let's see. I see the answer, but I don't want to lead us to the answer. We don't know what X is. But do you notice X is undergoing what? Combustion with oxygen. And in most cases, it's alkanes. Alkanes. And what would that give you? Carbon dioxide, water, plus energy. Telling me that it is what? Do you think I've answered A, B, C, D? What is A? Halogenation. What is B? Substitution. What is C? Substitution. What is D? Elimination. I'm done. Just by identifying which one is saturated, which one is unsaturated. No, they just say name the type of reaction. Don't go so far to say, except they tell you what type of substitution, what type of addition, what type of elimination. Make sense? I took to answer all of this, even with my explanation. Okay, can we get the rest? 10 minutes. Use condensed structural formula to write a balanced reaction for what? C. Can we go for C, my dear learners? We're going to finish now. C. What is happening with C? Guys, check. It's substitution, right? Can you draw? They said use condensed. Is it condensed or structural? Condensed. Please write. We are moving from here to here, right? Please write this equation down. C3H7Br. Reaction C. We are moving from B to C. Or let me try to do it here. Check. C3. Look, when it comes to this, you can play games. C3H7OH. You are moving from here to here. What do you notice? Are you aware that you are removing this guy and replacing it with what? This guy. And it's a what? Come back to my conditions. When do I have a substitution reaction? When I have a dilute strong, usually use a base. A dilute strong what? Base. Give me an example of a strong base. Sodium hydroxide. So plus, I don't know if you see what's going on. Do you notice I'm now replacing this with this? What's going to happen? This is going to replace this. So what do I have? Plus NaBr. I'm done. Substitution means you replace. All you need to know is the condition. And this is what? Dilute. And what? If they ask for the condition, Mild what? Heat. Can you see my CEDS working there? It's witchcraft. No, it's not. So I know that learners usually find this very difficult, but I always tell them, it's the simplest. Okay, are we ready? Are we ready? We're done with 4 marks. That was 4 marks. Just by you realizing that it's a substitution and the condition you need, dilute sodium hydroxide. Write down a structural formula for compound X. Guys, can I tell you something here? Apart from cracking or whatnot, the number of carbon atoms will remain the same. How many carbon atoms do you see here? Do you notice C3? C3, C3. This one is also what? C3. And we said it's an alkane. 3 times 2. 6 plus 2. 8. I'm done. Propane. The 3 is maintained on your table. And we said an alkane will react with oxygen to form carbon dioxide and water. So I know that's an alkane with 3 carbon atoms. What? Okay. Can we move on? Let's finish. Compound X undergoes combustion in the presence of oxygen. Write down the molecular formulas of the 2 products. I'm done. What are the molecular formulas? CO2, H2O. They said I should write down. They didn't say balance, but you must learn how to balance. Use structural formulas to write a balanced reaction for the reaction to produce what? Y. Let's go check. Which one is Y? Where is Y? Oh, beautiful. Reaction what? D. My beautiful learners, please check. I actually love this question. I'll tell you why I love it. C3H7Br plus, can you see it's KOH? Which I could have used here as well. But what are you saying? Concentrated what? KOH. What's going to happen? Elimination. Why? Because it's concentrated. Did they say what? What did they say? Structural, right? Sweet. Can we get those 3 marks very fast? Once you know what's going on, what do we have? C3H7Br. Let's draw the structure. C3, 1, 2, 3. H7. Are we okay with the H7? How many is that? 6. 1, 2, 3, 4, 5, 6, 7. Br. Do we agree? We are reacting it with what? Concentrated KOH. What are we expecting to eliminate? Which one do you think will be eliminated? Definitely this guy is going. Is that fine? Now, when you remove that, you cannot remove that alone. Listen, you cannot remove that alone. You have to go to the next carbon and remove the hydrogen. Why? Let me show you why you cannot remove that alone. Let's write what we have. If we remove that alone, look, play with this thing. You have an idea of what's going on. Check this. If I remove that, don't you notice I have a problem with my structure? Because definitely I am eliminating, so I'm forming what? Unsaturated. I need a double bond. There's no way I'm going to put a double bond here. How do you put a double bond if you have a structure like this? Be smart. One hydrogen must disappear. And which one? This is where you use the Zaitsev rule. The poor gets poorer. Okay, sorry. But this is what we say. The rich gets what? Why? Look at life. A rich person has money to invest. So they have, a rich person has money to buy food with. Check this. A rich person has, let's say, 5,000 on it. A rich person can invest 3,000 and buy food for 2,000. What's happening with 3,000? It's going to make more. A poor person, you give the person 2,000. It's food straight. They return back to that poverty level. The poor would get what? Poorer. But the rich gets what? Richer. Where do we use the rich gets richer? We use the rich gets richer when we add. Please listen. We use the poor gets poorer when we remove. 3 minutes. I want to finish. So I am removing BH here. I'll go to the next carbon and take the H. That is, I'm going to show you something here, or maybe tomorrow. What if the Br is in the middle? But for now, can we get rid of this guy? If we get rid of this guy, you know what's happening? Oh wait, do you know what I've done now? I can create my. Can I create my double bond? If I remove that, wait. 1, 2, 3, 4. Yes, 1, 2, 3, 4. Makes sense? Good. But because I removed that, it doesn't go away. Please watch. I have removed that. What do I have? HBr, which is a base, plus, acid, and what? A base. What do I form? Salt and water. KBr plus, and I'm done. Whenever we eliminate, water is formed. Huh? Because there's an acid there, so it's an acid and a base to form salt and water. Did that make sense? I don't know if it makes sense, guys. Just watch what is eliminated. You cannot remove Br alone. One hydrogen must go with it. And usually the hydrogen of the carbon that is poor, we punish him for being poor. Yeah. We ask him, where were you when others were making money? Buying food. We punish him again. All right, let's answer the last one, I think. Instead of heating concentrated, instead of eating what? Concentrated potassium hydroxide under reflux during the formation of Y, dilute sodium hydroxide is used. You know what they're asking? It's the first one we did. They said, instead of heating with concentrated, what are we using? Dilute. What's going to happen if we do dilute? Let me do that one here with you quickly, and we'll be finishing. Let's use dilute for the same structure. 1, 2, 3, 1, 1, 1, 1, 1, ta, ta, ta. I'm just drawing BR here. Plus, dilute what? KOH. What do you think will happen? Since I'm seeing dilute, what's going to happen? Substitution. This guy is going to replace that guy. So what are we going to have? 1, 2, 3. Do you notice that it will still be saturated? What will happen here? OH plus what? KBr. Can you name this compound? The one that is formed. How many carbon atoms? 3. So what is it? Propan 1 all. Please don't write propanol. It's propan 1 all. All right, last question for the day. We are all tired, including myself. To which homologous series does Z belong? Where is Z? That was answered when we were discussing. That's an ester. All right, guys, let's meet tomorrow. But I don't know if it makes sense, though. The whole thing makes sense. Look, to answer, what do you notice? That's the page. This is everything for question 4. Everything for question 4. Guys, have a lovely evening. Have a wonderful, wonderful evening. See you tomorrow when we do what? Rates, chemical equilibrium, acid and base. Hi, Jada. Hope you're good. Goodbye, Tina. Night. Bye, guys.